Hi everyone, this is Jagjit and we're going to be going over KSP questions. So in this question, they tell us that 0.0558 grams of SRF2 dissolves in 500 ml of water, and they're asking us to find the KSP. So the first thing that we need to do is we need to turn these grams into moles, okay? So we're going to take our 0.0558 grams of SRF2 and we're going to convert them into moles, okay? So we've got grams of SRF2 at the top. You're going to put the same unit at the bottom. And we're going to say 1 mole of SRF2 is going to be equal to its molar mass, okay? So I let you find the molar mass at your end. It should be equal to 125.6. Grams and grams cancel. You take this number divided by 125.6 and that's going to give you the moles of SRF2, which will be equal to 4.44 times 10 raised to the power minus 4 moles. So we have these many moles of SRF2 and we know these many moles are going to dissolve in 500 ml water. So now we're going to get the molarity, which is the concentration. Now guys, how do we get the concentration? We take our moles and we divide it by the liters, okay? So we have 4.44 times 10 raised to the power minus 4 moles of SRF2, and we're going to divide it by the liter. Well, it's 500 ml. What's 500 ml in liters? That's 0.5. Okay, we're going to take this number, divided by 0.5, and that should give you 8.88 times 10 raised to the power minus 4 molarity for SRF2. That's going to be our concentration of SRF2, and now they're asking us to find the KSP. So we're going to write the dissociation equation for SRF2. You're going to take your SRF2 and you're going to write the dissociation equation. Straight away we know it's going to be SR2 plus. Straight away from this 2 we know the charge is going to be SR2 plus. Aqueous plus F minus. Now there's one SR and one SR2 plus, so that's balanced. However, there's two F's and only one F minus over there, so we need to put a 2 in front. Now the concentration of SRF2 was 8.88 times 10 raised to the power minus 4. The molar ratio is 1 to 1. That means the concentration of SR2 plus will be the same. So that will be 8.88 times 10 raised to the power minus 4. Now this one has a 2 in front, so that means the concentration for that is going to be twice of that. So you're going to take this concentration multiplied by 2, and that should give you 1.777 times 10 raised to the power minus 3 molar. Now you have the concentration of each ion. We're going to write our KSP expression. That's just going to be concentration of SR2 plus times concentration of F minus. However, there's a 2 in front, that's going to become the power. You're going to plug in the numbers. So that's going to be 8.88 times 10 raised to the power minus 4 multiplied by 1.78, you can round it, times 10 raised to the power minus 3, but don't forget the square, folks. And now you're going to punch it in. Make sure you put brackets, and if you've punched it in properly, you should get 2.81 times 10 raised to the power minus 9. That's going to be your KSP for SRF2 at this particular temperature. Okay, we're going to do a couple more examples. Next up, the question says, find maximum concentration. Find maximum concentration of fluoride ion where concentration of Sr2 plus is equal to 5.0 times 10 raised to the power minus 3 molar. So straight away we know Sr2 plus is going to react with fluoride ion. Okay, Sr2 plus is going to react with F minus. So what's the formula for this going to be? You're going to crisscross the charges, so we get SrF2. So we're going to take SrF2. We're going to write the dissociation equation. You're going to get Sr2 plus aqueous plus F minus aqueous. But you need to make sure the equation is balanced. I have one Sr, one Sr2 plus, so we're good for that. The F's are 2. We have 2 F's over there. However, on this side we only have one F. So we need to add 2 in front. Now they did tell me that the concentration of Sr2 plus was 5.0 times 10 raised to the power minus 3. Now looking at the molar ratio, we know the concentration of F minus. That's what we're trying to find. So we don't know the concentration of F minus. Let's just call it X for now. Okay? Now guys, what we're going to do is we're going to write the KSP expression for this. The KSP expression for this is just going to be Sr2 plus times F minus. There's a 2 in front, so we're going to put that 2 in the power. Okay? So this is 5.0 times 10 raised to the power minus 3 times F minus, or we can say the concentration of F minus is X. So you can just write this as X squared is equal to KSP of SrF2. Now you're going to look at your chart, and the KSP for SrF2 is 4.3 times 10 raised to the power minus 9. So as a first step, you're going to divide both sides by 5.0 times 10 raised to the power minus 3. So you're going to get X squared is equal to 4.3 times 10 raised to the power minus 9 divided by 5.0 times 10 raised to the power minus 9. And then you're going to have to take the square root, because we're going to have to isolate X. So imagine we take the square root of this whole thing. Make sure you put brackets. If you've punched it in properly, you should get X is equal to 9.3 times 10 raised to the power minus 4 molar. And guys, as we had earlier said, that X represents the concentration of F minus. So that's what we were looking for. So guys, you need to be careful in these questions, okay? They were asking us to find the maximum concentration of fluoride ion that you can have when your Sr2 plus is this, okay? So you're going to have to write the dissociation equation, write the KSP expression. You know your KSP. They've given you the concentration of Sr2 plus, and you're just going to find the missing concentration for the fluoride ion, okay? All right, folks. Next up, the question says solubility of CaCO3 is 1.189 times 10 raised to the power minus 3 grams per liter. And the question is asking us to find the KSP. Again, they've given us solubility in grams per liter. In the very first step, we're going to convert these grams to moles. We're going to express the solubility in moles per liter. Okay? So we have 1.189 times 10 raised to the power minus 3 grams of CaCO3 per liter. Let's change it from grams to moles. We have grams of CaCO3 at the top. We're going to put the same grams of CaCO3 at the bottom. And 1 mole of CaCO3 is going to be equal to the molar mass of CaCO3. I'll let you find that at your end. However, that's going to be 118.9. You're going to cancel out the grams. You're going to take this number divided by 118.9, and that should give you 1.00 times 10 raised to the power minus 5 molar. Now guys, that's the molarity for CaCO3, okay? That's your concentration of CaCO3. And in the next step, you're just going to write the dissociation equation of CaCO3. You're going to get Ca2 plus aqueous plus CO3 2 minus aqueous. And again, guys, what was the concentration of CaCO3? That's 1.00 times 10 raised to the power minus 5 molar. Now, the molar ratio is 1 to 1 for each one of those. So the concentration of Ca2 plus will be the same. And CO3 2 minus will be the same as well. So we're going to write our KSP expression. That's just going to be concentration of Ca2 plus times concentration of CO3 2 minus, which is just going to be 1.00 times 10 raised to the power minus 5 times the same number. Again, guys, make sure you put brackets. If you've punched it in properly, you should get 1.00 times 10 raised to the power minus 10. And that's going to be your KSP. Okay? So hopefully by now you have a good understanding of KSP questions. Thank you very much.